motion in a straight line. Okay. So before we talk about motion in a straight line, we should understand that what is rest and what is motion. What is rest and what is motion. All right. So suppose if we talk about you, you are right now sitting at a place and you are watching this lecture, you are studying, correct? Now, if I ask you whether you are at rest or in motion, then what will be your answer? You'll be saying, sir, I am at rest. But if a person who is walking on the road or a person who is walking by you, for that person, you are in motion. If a person is sitting next to you, for that person, you are at rest. Correct? So, rest and motion an absolute. Rest and motion is not an absolute thing. Absolute thing means you cannot give a universal answer which is true for everyone and everything. So it's a relative thing. It's a relative thing. Relative in the sense it depends that who is observing. It depends on the person who is observing or the frame of reference through which you are being observed. The frame of reference through which you are being observed. So observer or frame of reference, these are the two terms which are used interchangeably, okay, alternatively. One term can be used in place of other and vice versa. So now using this understanding, let us define rest and then let us define motion. So an object is said to be at rest if its position if its position does not change if its position does not change with time with respect to a frame of reference. Okay. So an object is said to be at rest if its position does not change with time with respect to a frame of reference. Now, in this definition, there are three terms which are important. There are three terms which are important. First term is time. First term is time, that the position should change with time if object is in motion. Position should not change with if object is at rest. Now, what do you mean by with time? With time means when time is passing. That is the meaning of with time. Okay? And time flows by itself. Time passes by itself. You cannot do anything to stop that. You cannot do anything to start that. Okay? Time, motion of time or movement of time, or you can say flow of time, is happening by itself. Even if you remain idle, even if you are not there, even if you are not born, time will flow, time will pass. And even if we are not going to be here, time will continue to flow. All right. So it's a very deep phenomena related to time. We are not going into that detail. But yes, time flows, and in time we measure different things. That means in time we measure events. You born, that was an event. You studied up to your current status, that is a duration of time. You cleared your 10th exam, that was one duration of time. Then you cleared 10th to 12th, that is one duration of time, right? So that's how time flows, and with time events happen. You grew up in time, you cleared your so many exams in time, right? So time is one entity within which everything is happening. That's why it is important to talk about time. Now the second thing is frame of reference. Frame of reference. So what is frame of reference? Let us talk about that. So what is frame of reference? It is the entity. It is the entity about which motion is being observed. Motion is being observed. Okay. If you are saying you are at rest, that means you are talking in terms of your room. With respect to your room, you are at rest. Your position is not changing in the room. Or with respect to some corner in the room, you are at rest. Your distance from that corner is not changing. Or a person is sitting next to you, and with respect to that person, you are at rest. Okay. So try to understand your frame of reference can be anything. Frame of reference can be anything. It can be a living object. It can be a non-living object also. The corner of the room is non-living. A person sitting next to you is living. Your frame of reference can be at rest also. If a person is sitting next to you, that's a stationary frame of reference. But if the same person starts moving or some other person starts moving, so that will be a moving frame of reference. Frame of reference can be unaccelerated also. It can be accelerated also. Can be accelerated also. So frame of reference can be living slash non-living, stationary slash moving, unaccelerated slash accelerated, etc. Okay. So there can be various attributes of a frame of reference. It can be colorful, it can be without color also, though it is meaningless. Though it is meaningless, but you can talk about that attribute also. Frame of reference is sometimes also called observer. It is also known as observer. Okay. So basically, when we use word observer, it seems that somebody is observing. So we, get a feeling of a living object or like some CCTV. But there is nothing called, observing. It can be non-living also. So frame of reference is a more technical term as compared to observer. But yes, observer is also often used. All right. Okay. So this was the second term. Acha, be very clear. If suppose nothing is mentioned in the question that what is the frame of reference. For example, if it is given a car is moving with a speed of let's say 100 km per hour. So if nothing is mentioned specifically as observer, then ground should be taken as the frame of reference. Okay. If frame of reference is if frame of reference is not explicitly mentioned, if frame of reference is not explicitly mentioned, then ground should be taken as ground should be taken as and ground should be taken as frame of reference. Okay, ground means earth. All right. Example, if A car is moving with speed 80 km per hour. Then that speed is given. That speed is given with respect to ground. Okay. Okay. Be very clear that without defining the frame of reference, this is very important. Without defining frame of reference, without defining frame of reference, there is no meaning of there is no meaning of rest or motion. Rest or motion. Okay. Same object can be stationary or it can be moving at the same time depending on who the observer is or what the frame of reference is. You are sitting right now. If a person is sitting next to you, for that person you are at rest. But if some other person is walking, for that person you are moving. Okay. Same object, same person, same thing can be stationary or it can be moving depending on what our frame of reference is. What our frame of reference is. Be very clear and particular about this. Okay? Good. Now, the third thing which is there in the definition is position. Is position. So what is position? So in your room, when you are sitting right now, imagine a corner or you can choose a corner, and in that corner, imagine a small insect. In that corner, imagine a small insect or ant. Okay, and that insect is looking towards you directly. So with respect to that insect, you can draw a straight line which reaches up to you. With respect to that insect, you can draw a straight line which reaches up to you. That straight line will be called your position with respect to that insect. Okay. So what is position of an object? So basically position is always defined with respect to some frame of reference. Position is always defined with respect to some frame of reference. In this case, the frame of reference is our insect. In this case, the frame of reference is our insect. So with respect to that insect, where you are sitting, you are drawing a straight line joining to these 2 points, and that creates your position. That creates your position. All right. So arrangement in space. Arrangement in space of an object. Of an object with respect to the observer. With respect to observer is called position of the object. Is called position of the object. So here to define position, it is very important to know that what our frame of reference is. Unless we define the frame of reference, we cannot talk about the position. If I ask you, what is your position in the room? Then you will get confused. Sir, I am in the room. I said, okay, that is fine, but where in the room? Sir, I am in the room slightly left. Your left, my left. Are you getting the point? So, sir, I am 2 meters from the corner. Which corner? There are many corners in. So we have to be specifically decide that okay, with respect to this corner, I am 2 meters in right direction. So if you do it that way, it becomes more clear. Okay, that's why frame of reference is very important. That's why frame of reference is very important. So suppose we are considering this as our frame of reference. This is x-axis, this is y-axis, and this is point P, and this is point P, and this is our origin. This is our origin. You can call it 0, 0. Okay. You can think that insect is sitting here at point O. At point O. And that insect is observing point P. That insect is observing point P. Coordinate of point P are x, y. So position. So position of point P with respect to O will be the line OP. Will be the line OP. Okay. So this is OP will be equal to R vector. OP is position of point P with respect to O. Okay. So if an object is kept at point P x, y and observer is at O 0, 0, then position of P with respect to O will be R vector is equal to OP vector. You are joining point O to P, so it is from O to P. So that is why it is OP vector. And that OP vector can be written as, now coordinates are x, y. So x, now what is unit vector along x-axis? It is I cap plus y. What is unit vector along y-axis? It is j cap. So R vector will be xi cap plus yj cap. Okay. So this is in vector form. Hence distance of point P, with respect to O, that is OP is equal to R is equal to x square plus y square. So OP is equal to R is equal to x square plus y square. Please note everyone. Please note. Okay. So question. An object is kept at point P 6, 8, 6, 8, Find position vector of object. Position vector of object. Number 2, distance of point P from distance of point P from O. Quickly give me the answer. Quickly. You should not take more than 30 seconds to give both answers. Very nice. See, whenever I give any question, all of you should give your answers. Try to understand, even if someone else has given the answer, that doesn't make it your answer. Okay? When you solve something, you should answer. You should write your answer on the screen, chat box. Okay? Because you are studying, preparing for yourself. Be very particular about this fact. Alright? Even if all of them give answer, then also you are supposed to give answer. Why? Because you are studying, preparing for yourself. Understood? This is very important. When you don't give answer, that means you have decided that okay, let these people go ahead, and I'm happy and okay with where I am, which is not a correct temperament. Which is not correct temperament. We need to develop the temperament of go-getter. That everyone has answered. I need to study and I need to answer for myself. All right. Keep this thing in mind always. Reminding, but still. Okay. Smart people are those who learn just from a little bit of hint. Okay. Okay, everyone. Please pay attention. So OP vector will be R vector is equal to 6i cap plus 8j cap. So this is your vector form. So distance will be, that means magnitude. Distance is equal to magnitude of OP vector, and that will be under root of 6 square plus 8 square, and that is 10 units. Okay. So that is our answer. That is our answer. All right. Good. Good. Now, if you notice, we have left one definition, which is motion. Rest we have defined. Let us get back to the motion and define it also. So what is rest? An object is said to be at rest if its position does not change with time with respect to a frame of reference. So what will be the motion accordingly? An object is said to be in motion. An object is said to be in motion if its position changes with time, if its position changes with time with respect to a frame of reference. An object is said to be in motion if its position changes with time with respect to a frame of reference. To a frame of reference. All right. So an object is said to be in motion if its position changes with time with respect to a frame of reference. All right. Good. Now let us move further. Basically, now we are moving towards displacement. Now we are moving towards displacement. and try to understand. This is x-axis, this is y-axis. An object is initially at point P. This time we are taking it as x1, y1. Okay. An object is initially at point P and coordinates of point P are x1, y1. From P it goes to Q and coordinate of that point are x2, y2. Okay. So try to understand what is happening. First, initial position vector of object will be OP vector. Initial position vector is OP vector. Final position vector will be OQ vector. Final position vector is OQ vector. So this is O, this is this. So an object, let me write it in words also so that it will be helpful for you to note. An object is initially at point P, x1, y1. Okay. From here it goes to Q. It goes to point Q, x2, y2, x2, y2. So initial position vector, initial position vector, initial position vector. So R initial is equal to OP vector. R initial is equal to OP vector, and that will be x1 I cap plus y1 j cap. All right. Now when it has reached to point Q, it will have final position vector. So final position vector, and how much that will be? That will be R final. That will be OQ vector, and that will be x2 I cap y2 j cap. All right. So if we want to know that how much the object has traveled, how much the object has traveled or shifted. So it has shifted from P to Q. So that will be PQ vector. Okay. So displacement of object. Displacement of object is equal to shift is equal to delta R is equal to PQ vector. You can see that PQ. This is PQ vector. This is OP vector. This is OQ vector. All right. So if you want to use triangle of vector addition here, just to give you the idea. So by triangle law, we are applying this separately. Okay. So what you can see is OP vector plus PQ vector is equal to OQ vector. Correct? Because triangle of vector addition says if two vectors are such that the tail of second vector starts from head of first vector, then their resultant will be from tail of first vector to head of second vector. So OQ vector is our resultant basically. Okay. So now from here, if we want to know how much is PQ vector, so PQ vector will be nothing but OQ minus OP. So let us write it here. So PQ vector is equal to OQ is x2 x2, let me use this color. So x2 I cap plus y2 minus x1 I cap plus y1 j cap, and that comes out to be x2 minus x1 I cap plus y2 minus y1 j cap. So this is our PQ vector. This is our PQ vector. This is the PQ vector. Mind it. That is also equal to displacement. So before we talk about definition of displacement, let me give you a question so that you can solve and you can get understanding. An object is initially at point P, and I am taking this point as 3, 4. From here it goes to point Q, and that is 6, 10, no, not 10, 8. Find displacement of object. Find displacement of object and its magnitude. So you need to find displacement in vector form and its magnitude also. Again, you should not take more than 1 minute. Okay. So you can solve this question by 2 ways. Let me tell you both the ways. Method 1. So R initial will be 3 I cap plus 4. R final will be 6 I cap plus 8 J cap. Okay. So delta R, which is displacement, R final vector minus R initial, and that will be 3 I cap plus 4 J cap. Let me write it also, which is 6i plus 8j minus 3i plus 4j, which ultimately comes out to be this much. And now that gives you delta r is equal to under root of 3 square plus 4 square, which is 5 units. Okay, this is method 1. Method 2. So delta r vector is equal to x2 minus x1 I cap plus y2 minus y1 j cap. Now x2 minus x1 is 6 minus 3, so 3 I cap, or let me write it as 6 minus 3. So 6 minus 3 I cap plus 8 minus 4 j cap. So this gives you 3 I cap plus 4 j cap. So that gives you delta r is equal to under the root of 3 square plus 4 square, which is 5 units. All right. So that is how we get the answers. All right. Okay. Both methods are easy. You should choose that which one is appropriate for you. Now, the methods which we are learning, if you pay attention, the methods which I am teaching you, these for that you don't require too much of memorizing of formulas. Okay. Your basic understanding will help you in solving all these type of questions. So now let us move further and talk about displacement. So what is displacement? So displacement, shortest distance between any 2 points is called displacement. Shortest distance between any two points is called distance. Shortest distance between any 2 points is called displacement. All right. It's a vector quantity. SI unit is meter. SI unit is meter. Dimensions are m naught because mass is 0, L1 T naught, m naught L1 T naught, m naught L1 T naught. Okay, so this is dimensions. Now there are some key points related to displacement. Which are those key points? Please pay attention. Displacement between any 2 points is unique. Displacement between any 2 points is unique. Displacement between any 2 points is unique. Now, what do you mean by displacement between any 2 points is unique? Try to understand. Suppose you are starting from point A and you are going to point B. All right. You can go from A to B on this path. You can go from A to B on this path, or you can go from A to B on this path also. Now, if you are going from A to B, there can be numerous paths. Numerous means infinite paths, in fact. We have just drawn 3 points or 3 paths, but there can be infinite paths to go from A to B. But displacement between these 2 points A and B, that will be unique, and it will be along the line joining the 2 points. It will be along the line joining the 2 points. Which is that line? Let us see. This is our displacement, and that is RAB vector. Okay, so displacement between any 2 points is unique, and it is along the line joining. It is along the line joining the 2 points. Okay, displacement will always be along the straight line joining the 2 points. Got it? Okay. Next point. So displacement between 2 points is unique. Direction of displacement is always from initial point to final point. Direction of displacement. Direction of displacement is always from initial point to final point. Okay, direction of displacement is always from initial point to final point. That means in this case it is from A to B. Okay, next point. Displacement can be positive, negative, or even zero. Displacement can be positive, negative, or even zero. Okay, so displacement of any object can be positive, negative, or even zero. How this can happen? Let us see. So suppose an object is here at point O, okay, and this direction is taken as positive. That means right side is taken as positive. So if object moves in right direction, if object moves in this direction, displacement will be positive. Displacement will be positive. Okay, but if object moves in this direction, displacement will be negative. Okay, now what happens if the object returns back to the same point? Its displacement will become zero. If object returns back to the same point, its displacement will become zero. All right, if object returns back to the same point, its displacement will become zero. Okay. So that is how the displacement will be positive, negative, and zero. All right, good. Now, rather than solving questions of displacement here, first talk about distance, and then we'll be solving questions of displacement and distance together. So distance now. Distance. Length of actual path traveled is called distance. Length of actual path traveled is called distance. Okay. Length of actual path traveled is called distance. So if an object is starting from here A and going to B, and if it goes like this, then whatever it has traveled actually, that will be the distance. That will be the distance. So actual length of the path traveled. It's a scalar quantity. It's a scalar quantity. SI unit. SI unit is meter. SI unit is meter. Dimensions is M naught, L1, T naught. Some key points. Distance can never be negative. Distance can never be negative. Okay. Distance can never be negative. Now what does it mean? Try to understand. If an object is at rest, how much distance it has traveled? Zero. If object is moving, the distance will be positive. That means distance will either be zero or it will be positive. So the expression can be written as this. Distance is always greater than equal to 0. This is very important. Next point. Distance cannot decrease after reaching to a certain value. Distance cannot decrease once it attains any value. So try to understand, there is an object which starts from its place and it has traveled 50 meters. All right. So it has traveled 50 meters. Just let me give you an example also with diagram. So this is point A, an object goes to B and distance traveled is 50 meters. Now if it becomes stationary at B, if it stops at B, its distance will remain 50 meter. But if it moves further in any direction, its distance will be increased. Okay, whether it goes in any direction by 2 meters, it will become 52. It will not become 48. Okay, because distance is always increasing, it cannot decrease. All right, so keep that thing in mind also. This question, this thing can be asked in some graph, in which what happens, a distance is increased, then they are trying to show it to go down. No, that's not possible. Distance increase. Okay. So if you find such diagram, such graph, you can clearly say that it is not possible. So this graph is wrong. Next point. For the same motion, distance is always greater than equal to magnitude of displacement. Now there are a few things which we should understand in this. First of all, if you notice, we are comparing distance with magnitude of displacement. We are not comparing distance with displacement. Do you know why? Because displacement is a vector quantity. You cannot compare a vector quantity with a scalar quantity. So what we did, we took the magnitude of displacement, and when we are taking magnitude of displacement, we are comparing a scalar with another scalar, because magnitude is a scalar quantity. Okay, so So this you should keep in mind. You can compare a scalar with a scalar. You cannot compare a scalar with a vector. Now the second thing, distance is always greater than or equal to displacement magnitude. What does it mean? Suppose an object is moving along a straight line. It is starting from A and going to B. So when it is going on a straight line, distance will be equal to displacement. I am talking about magnitude, correct? Suppose if it is going like this, then you can automatically say that distance is more and displacement is less, right? So in which case distance and displacement both will be, so tell that distance equal to displacement only if an object moves along a straight line without changing its direction. This is very important. Distance will be equal to displacement. Distance will be equal to displacement. Distance will be equal to displacement only an object if an object moves along a straight line, moves along a straight line without changing its direction, without changing its direction. Okay, understood? So if object keeps on going in a straight line in the same direction, if it returns back, then also distance will be more and displacement will be less. Okay, good. So these were the few points which are important. So we talked about it. Now I'm going to give you some questions which you need to solve. These are easy questions. You'll be easily able to solve them. So an object is starting from point A, this point is B, this point is C, this point is D, and this point is E. The path you can see is semicircular. Radius is R is equal to 2 meters. Here also radius is same. R is equal to 2 meters. So the question says an object moves on path A, B, C, D, E. Find distance and displacement. Find distance and displacement during number 1 AB, number 2 AC, number 3 AD, number 4 AE. Okay, so this you need to find. Please find everyone. Okay. Okay. Okay, everyone, please pay attention. If we see the circumference, okay, if we calculate the circumference, because it's a circular path, semicircular, or you can say circular. So circumference, and let me call it S. So that will be equal to 2 pi r. So that will become 4 pi. So the complete circumference, if it will 4 pi. So AB is 1/4 of S, correct? So AB, this is distance, then displacement. So AB is S by 4, so that will be 4 pi by 4, and that is equal to pi. So distance AB will be pi. All of them are in meters. Meters. So how much will be AC? Pi plus pi, that is 2 pi. How much is AD? Pi plus pi plus pi, because this plus this plus this, correct? So it will be 3 pi. It will be 3 pi. And AE, it will be 4 pi. Okay. Now let us talk about displacement. So displacement AB will be this straight line. Now you can see this is 2 meters. This is 2 meters. So this will be under the root of RAB. I am writing. RAB is under the root of 2 square plus 2 square, and that will be 2 root 2 meters. This comes out to be 2 root 2 meters. Correct. Now comes RAC. RAC will be this. So which will be 2 plus 2 will be 4 meters. RAC will be 4 meters. RAC is equal to 4 meters. Then comes RAD. So this is 6. This is 6. And this is 2. And what do we need to find? We need to find this. That will be RAD. And that will be under the root of 6 square plus 2 square. That will be root 40. That will be root 40. Okay. And RA 2 plus 2 plus 2 plus 2, 8 meters. This is the answer. This will be the answer. How many of you solved it correctly? All parts. How many of you solved it correctly? All parts. How many of you solved correctly all parts? Okay. Okay. Kimaya, your third displacement was not correct. You were saying only 6 meter. All right. All right. Next question. Yes, yes. This are the stairs. So this point is O and this point is A. Length of each stair is 1 meter and height of each stair is also 1 meter. Okay. A ball has been rolled from O. A ball has been rolled from O and it reaches to point A. Be very clear that it is rolling, it is not bouncing. It is not bouncing. So a stair has height and width 1 meter for each step. Find distance and displacement. Find distance and displacement as ball goes from O to A. Okay, so you need to find distance and displacement both. Please find quickly. Hmm. Hmm. When two people get similar wrong answer, one person goes and likes other person's answer. See, similarity gives you confidence, even if that is wrong. Correct? Everyone, please pay attention. Please pay attention. Now pay attention. This is 1, 1, 1, 1, 1, 1, 1. So distance will be, let us count. It's a very interesting task. 1 plus 1 plus 1 plus 1 plus 1 plus 1 plus 1. Okay, 7 meters. And people are so happy to find that answer. Correct? Okay. Now, let us see what people are doing. Okay? Let us see what people are doing and let me tell you how people are doing it. People are solving this as root 2, this another as root 2, this another as root 2. So this becomes root 2 and this is 1. So answer is 3 root 2 plus 1. That's what people are doing, but they are wrong. But they are wrong. Why? Because displacement is not calculated like this. Displacement is calculated joining initial point and final point with a straight line. Displacement is calculated by joining initial point and final point by a straight line. Now, how to find the actual value of that? So for that, we have to understand that what is happening. If you see, then this is how much, and this is how much. So this value is 3 because these are 3 steps which you are coming down, and this value is 4. So if this is 3, this is 4, then this will be under the root of 3 square plus 4 square, and that will be 5 units. That will be 5 units, and that will be the answer. Answer will be 5 units. So displacement will be 5 units. People became very creative. They got 3 root 2 plus 1, 5 root 2, 5 root 2. Some got 4 also. Some got 5.242. How did you get this 5.242? Some got 2 root 2 also. Very nice. Displacement, some got 4 also. Good, good. Some got displacement is equal to 3. Hmm. How did you get? Okay, next question.
I just did not like the answer, sir. Otherwise, it's same as 3 root 2 plus 1.
Okay, very nice. Okay, all right. Next question. Next question. There is an object which moves 5 meter, then 3 meters, and then 4 meters. Like this. This point is O, this point is A, and this angle is 53 degree. So the question says an object starts from O. An object starts from O and goes to A. Find number distance. Number 2, displacement. Please find. Please find. Hmm. Okay. What are you saying, Gauri? Sir, shouldn't be the vertical 3 meter and be 4 meter and horizontal be 4 meter and 3 meter? I couldn't get you. Whatever is written on the screen is the question. Don't try to
So the
what we can say
angle
miss.
angle A is 53 degrees.
Yeah, angle is 53 degree.
So opposite to 53 should be 4 meters, no sir?
See, I don't know much about all these things. I know that this is the question which is to be solved. Okay.
Okay.
Yeah, you guys need to solve and help me in solving this.
Okay.
Yeah. Don't try to confuse me. Everyone, please pay attention. Enough time given. Distance is very difficult to calculate. 5 plus 3 plus 4. 5 plus 3 plus 4. And that becomes 5 plus 3 is 8. Then you are adding 4. That becomes 12 meters. Okay. Now, if you see the displacement part, listen very carefully. So this 3 and this 4 will be 5. Correct. Under root of 3 square plus 4 square will be 5, this straight line. And then people are saying that, sir, 5 plus 5 is equal to 10. Correct? But they are wrong here. This 5 plus 5 will not be 10 because this 5 and that 5 is not along a straight line. This 5 and that 5 is not along a straight line. So what we need to do is pay attention. Basically, we are trying to find OA. We are trying to find OA. So for that, what we need to do, we need to join them by a straight line. We need to join them by a straight line. All right. And if we are trying to find that, let us see what will happen. Let us see what will happen. Pay attention, everyone. This 5 meter and angle 53 degree is given to us. So I am going to resolve this. So this will be 5 cos 53. This becomes 5 into 3 by 5. That becomes 3. So this is 3 meters. Similarly, this height will be 5 sine 53. And that will be 4. Okay. Now if you pay attention, then this is 4 and this is given as 3. Similarly, this is given as 4. So x coordinate, x means this. So x is equal to 3 plus 4 is equal to 7. Y coordinate is equal to 4 plus 3 is equal to 7. So while you are reaching at A, how much you are traveling along x-axis? 7. While you are reaching at A, how much you are traveling along y-axis? 7. So how much will be your displacement OA? So OA will be under the root of 7 square plus 7 square. Okay. And that was 7 root 2 meters. Now let me tell you what people were doing in this question. Rather than getting the correct answer, they were trying to convince me to change the value in question so that they get answer as 10 conveniently. Right, Gauri? Yes or no?
Yes,
Tell
sir.
me. Yeah,
Yes.
so she was trying to convince me, sir, I think you have made some mistake. Answer should be 10 and as per that answer, the value should be like this. I said, no, 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 no. What I have given is correct. You get the answer as per the values given. Understood? So people try to, change the question as per their convenience. Don't do that. Don't do that in exam. Okay? Solve the question the way it is given rather than what is convenient to you. All right? Okay. I hope you all have noted. Now we are moving to next question. It's a simple question. An object is starting from A, B, C, D, and this point is O. R is equal to 5 meters. So an object starts from A and moves along BCD. Find distance and displacement during number 1 AB, number 2 ABC, number 3 ABCD, number 4 ABCDA. Please find. Please find.
So,
Yes,
so what is the radius?
5 meter.
Okay, sir.
It is written R is equal to 5 meter. Okay, to be more clear. Okay, everyone, please give quickly answers. All of you. So again, AB is 2 pi r SAB, I am saying 2 pi r by 4. So 2 pi r means 10 pi because r is 5 by 4. That means 5 pi by 2. So distance AB is 5 pi by 2. ABC is 5 pi. Then 15 pi by 2. And then 10 pi. Then 10 pi. So this is distance. This is distance. Now displacement. Now displacement. So displacement AB will be R root 2. So that will be 5 root 2. AC will be 2R. That means 10. AD will be again 5 root 2. And ABCDA will be 0. If you have any thing to discuss in this, please feel free to discuss. If you have any doubt, any question, you can mention right now. Okay. Okay, everyone. So that is enough for today. Keep solving questions, keep practicing. Solve lots and lots of questions because that's how we learn. All right.